Alright guys, so let's look at example number 2, question number 2 on how to solve questions as regard to magnitude and direction of coplanar forces, right? Also looking at resolution of forces. So I said my own method, the easiest way of solving this is to resolve the forces into two components, right? Let's start with our x component. Since we're resolving to the x component, we're resolving the cos, right? So our first force, which is 15, we're starting from our line here. This is our static line. We're moving here. This is the first one. You can see it covered an angle of 30 degrees. So this is 15 F1. That's 15 cos what? Cos 30 degrees. That's the first thing to do. I've already shared these steps with the first video, right? Plus, if we're moving here, so from here down to here is 90. 90 plus this 30 here gives us 120. So that will be 20 cos what? 20 cos 120 degrees, right? Plus what? What other force do we have? We have this force. So starting from here, this is 90, right? This part is 180 if we try and resolve it, and this part is what? 270. So we have 30 cos 270. And we have 30 cos 270 degree. Plus, move here, from here down 90, 180, 270. That means we need here. If here is 60, it means here is 30. Because look at this line, this is the angle 90, right? I showed you how to do this with the free body diagram. So this is 90, 100, the angle 270 plus this 30, that should be 300, right? So we have 10 cos 300. So let's try that, degrees, please. Let's try to see what we'll get. So 15 cos 30. All right, so I have to pause the video so that I can help you solve them. All right, that will save time. So 15 cos this give us 12.99. 20 cos 120. Use your calculator please to confirm. Give us minus 10. 30 plus 270 give us 0, and then 10 cos 300 give us 5. We add them up. We're going to have 7.99, approximately 8. Right, depends on what you want to use. So let's try to the y-axis. E f of y, that should be sine, right? So it's very simple. We just change all the cos here to sine. I haven't arranged that. So we have 15 sine what? Sine 30 plus what? 20 sine 120 degrees plus what? 30 sine what? 270 degrees plus 10 sine 300 degrees. So let's solve that. What do we have? So 15 sine so let's add to see what we're going to get. So we have 7.5 plus 17.32 minus 30 minus 8.660. By doing that, we had minus 13.84 Newton. That's what we have. Alright, so we now have our x and y axis. So we'll draw a line. So now since this y, you are seeing minus here, what it means is that our y is going to be in the downward. You know, in Cartesian form, it's like this. Alright, this is plus y plus x minus x and minus y. So what we have here, what this line means is that the x-axis is plus 8 Newton, which is this, but the y-axis we got minus, so it's coming down. Consider it's coming down. So we're going to draw it in this format, this and this format. That's how we're going to draw it like. That's how the diagram is going to look like. So whenever we're having minus, be careful to know how to draw your diagram, right? So in drawing that, we're going to have it like this. The y-axis is going to come down, and the x-axis is going to go this way, but they're going to be the same thing. It's all the same thing. I'm just showing you how it's going to be drawn. All right, so our resultant, what we're looking for, the x-axis, we got what? Our EF of x, we got 8 Newton, right? And then our EF of y, what we get? We got minus 13.84 Newton. Alright, so let's get our resultant. You know that our resultant is the square root of what? EF of y all squared plus what? EF of x all squared. So by doing that, our arrow gives us what? What's our EF of y? Minus 13.84 Newton all squared plus what? Our EF of s give us 8 Newton, 8 all squared. So by doing that, what our arrow going to be like? Our arrow, that's our resultant force, is going to be, let's try to the calculator. We're going to have the square root of minus 13.84 all square plus 8 all square. We're having 15.98. That's 15.98 Newton. That's our resultant force. Right, so let's get our angle, right, our direction, right? The same thing. Our theta is going to be what? They said it's going to be shift tan. That's the inverse of tan of EF of y to EF of x. By doing that, our inverse of tan of EF of y is what? 13.84 minus 13.84 over our EF of s is 8. Right? Let's see what we're going to get. So if we do that, shift of tan, that's inverse of tan, for minus 13.84 and 8. By doing that, we got minus 59 point what? 97 degrees. So I'll show you what this means. What that simply means is that our theta, let me just use this part please, because that's not the original answer for our theta. When you have minus like this, our theta is simply 180 minus what we have there, minus 59.97. So what we're going to get if we do that, so 180 minus 59.97 is going to be what? 120.03, approximately 120 degrees. So please take note for you guys that are solving questions as regard to this. I see in many cases whereby our theta is giving us minus and you leave your answer like this. Please, this is not the answer, right? You subtract it from 180 to get your original answer. I hope I have been able to assist you guys in solving questions as regard to the resolution of vector coplanar force, right? When you're seeing questions like this, I know there are other ways. Teachers teach you with other method, but this is the easiest method and the easiest form. Instead of looking at the one that is minus, trying to get the one that is minus, changing cos to sine, changing sine to cos, it's very easy. When you see s, just put, this is how I know, cos, right? Cos is the same thing as cos theta, right? And sine is syn, right? Same thing as sine. Right, you see, so I can use my y like this to know that I'm talking about sine, and the s, yes, to use something about cos. So it should not confuse you. Resolving to the x-axis, we're working with cos. Resolving to the y-axis, we're working with what? Sine. Very simple. Right? I hope I'm able to assist you guys to make your work, to get your solution more easier. I'll see you in the next video. Now, in the next video, we're going to be looking at how to apply this to real-life problem. Right? We'll be looking at it in our applied mechanics 1, right? To try and solve this using applied mechanics 1. We'll take one tough questions and apply this strategy to solving those questions. I'll see you in the next video, guys. Thank you.